video is going to help you answer questions in section 2 of your Google form. I believe questions 15 through 18. So this is investigation 14 in your week 8 assignment. Our focus question for this week: how do we use waves to communicate information, and which signal is most reliable, analog or digital? So up until this point, we've been learning about what a wave is, the different kinds of waves, and how waves interact with matter. Well, now let's take and apply waves to the real world. So how do we communicate information? Light and sound waves can be used to communicate information. Some ways are more effective than others, and we're going to talk about that. Can you think of some examples of how we use light and sound waves to communicate information? An ambulance or a fire truck siren and a car horn or a truck horn, a train horn, are all examples of how we use sound waves to communicate information. A stoplight, a lighthouse, a flashlight are just some examples of how we use light waves to communicate information. Let's talk about wave applications, analog versus digital signals. I want you to think of 2 clocks on a wall. One of them is digital. That one's on the right at the bottom and has numbers that change as time passes. The other is an old-style analog clock with a long hand and a short hand that rotate around the clock to show the time, bottom left corner. Which one is easier for you to read? Most people would say that the digital clock on the right is easier to read because instead of having to figure out what the location of the hands mean on the analog clock, you can simply read the numbers. Thinking about the examples with the clocks is a good way to think of digital and analog signals. Can you think of other examples of analog and digital technology? Here, I'm going to show my age. So a VHS tape is an analog technology, while a CD is a digital technology. And that's that first picture over there on the right. I grew up watching VHS tapes. A cassette tape, that is the yellow square tape on the right-hand side, is an example of analog technology versus a CD. So I owned cassette tapes before I bought my first CD in 7th grade. I believe it was TLC. That was my first CD. You can look them up. A record player is an example of analog technology. Your grandparents probably still have old records and a record player sitting around in their house. A floppy disk. I did have to use a floppy disk to save all my work. So while your work saves automatically now and uploads to the cloud in your Google Drive, we actually had to insert these little devices into our computer to save our papers and any work that we did on the computer. It wasn't until high school that a jump drive was invented, and we could get rid of the floppy disks and hold more data on a jump drive. Jump drives are now obsolete because of the cloud. A stop sign is an example of an analog technology versus a stoplight. And then a phone with a cord is an example of analog technology versus a cell phone, which most people use nowadays for digital technology. So we've learned that waves carry energy from one place to another, but did you know that sometimes that energy can be used to send information or data from one place to another as a signal? For example, waves carry sound signals from radio towers to the radio in your car. Waves also carry the sounds and images needed to watch a television show. One thing that is important to know is that there are different kinds of signals. In the past, all of the signals that were sent were analog signals. Analog signals were sent using the entire wave. If we think of the radio example, the radio would need to receive the entire wave and then use differences in the waves. So differences in amplitude for AM radio or differences in frequency for FM radio to signal changes in the sounds. This could be complicated because the wave might have received interference along the way that distorted the signal that the radio received from the tower. It also made it difficult for radios to receive signals from far away since the wave might not be able to maintain the same properties for long distances, especially if it had to pass through different types of matter, like different solids and liquids and gases. Now, today, most of our communications come from digital signals. Digital signals don't use the entire wave to carry information from one place to another. Instead, digital signals pull samples from the wave and then convert those samples into a code called binary code. And there's a video here, and I will put this video in the comments or in the description section of the form if you wanted to learn some more information about what binary code is. So binary code only uses two digits, ones and zeros. The ones and zeros are used to represent the differences in a wave and a device, like your radio, TV, smartphone, or tablet, which translates the code into a language that it can use to deliver the information from the code to you. Think of a remote control on a TV. The remote control uses electromagnetic waves to send a digital signal in the form of a code like 000110000 to your television. The TV recognizes that code as the signal to turn up the volume one level. If we wanted to turn it up two levels, the code might read 0001000 or something like that. This is just a simple example of how digital signals can be used to transmit information. Digitized signals are more reliable than analog signals. This means they can transmit information over long distances without the original message being distorted. They can be reproduced many times without losing the quality of the original message. Also, they can be interpreted by a device easily and precisely. It is much easier to read a binary code and know exactly what it means than it is to try to read the differences in amplitude or frequency in a wave, which might change if the wave experiences interference or a disruption. For all these reasons, digitized signals are more reliable than analog signals.
My girl wants to party all the time, party all the time, party. What? It's a catchy song. Dear Tim and Moby, what's the difference between an analog and digital recording? From Xander. Analog and digital are two different ways of storing information. Analog, the older of the two technologies, is based on the electromagnet. Analog media, like records and tapes, store complete sound and light waves as representations of an electric current. Digital technology is based on the microchip. Digital media, like CDs, hard disks, and flash memory chips, store parts of sound or light waves as ones and zeros, or bits. Well, alright, let's get practical. Say you want to record your voice. Whether you store it on a digital or analog medium, you need something to convert the sound waves from your larynx into an electric signal. And that's what microphones are for. Hello, this is Tim. In an analog device, this electric signal passes through a wire wrapped around a piece of metal containing iron. As current passes through the wire, the metal becomes an electromagnet. That's called electrical induction. Electricity induces a magnetic field in the metal. Changes in the electric signal result in changes to the magnetic field. These changes are recorded as a pattern onto analog media like magnetic tape or a wax record. When you play the tape or record, the playing device converts the pattern back into a signal. The signal is sent to a speaker where it comes out as sound. Hello, this is Tim. All analog devices work by this same principle. Electromagnets make a representation of a sound or light wave. Digital is a different story. Hello, this is Tim. In a digital device, an electric signal goes to something called an analog to digital converter, or ADC. The ADC analyzes the signal and takes samples of it. Well, analog devices record an entire wave. That means you're sure to get a true reproduction of sound, but the storage space required is enormous. Digital devices record millions of pieces or samples of that wave. Recording pieces requires less space than recording the whole. Well, it's like if you draw a face with lines, and then draw one made up of dots really close together. The dot drawing uses less ink, and from a distance, they look the same. Your brain fills in the missing information. The more samples taken per second, the more similarity, or fidelity, the digital wave will have to the original wave. This is called sampling frequency. Each sample's amplitude, the height of the sound wave, is described by a number. The more numbers available to describe the amplitude, the higher the sampling precision. You can think of sampling precision like a paint set. The more colors you have in the set, the more realistic your paintings can be. The analog-digital converter converts the stream of samples into ones and zeros. These are coded onto a medium like a CD or a hard disk. To change the ones and zeros back into an electrical signal, digital playback devices use a digital-to-analog converter, or DAC. Hello, this is Tim. Well, there are a couple of advantages to digital. First of all, the file itself doesn't deteriorate, and you can make infinite copies without losing any information. Plus, you can fit more data onto smaller devices. Digital data can also be compressed or shrunk down even further. But some people say that analog media just looks and sounds better than digital. And things like CDs have a relatively short lifespan, especially if they were blank CDs to begin with. After as few as 2 years, some CDs will just stop playing properly. So you have to copy or back up your files to ensure that they will last, which can be a royal pain if, say, you have a big music collection. I guess it all just depends on what you're looking for, or what you're listening for. So, what are you listening to?